Trigonometric. I can never spell this word. Ratios. I am going to write trig in a second. Okay? All right, let's do this. So your essential question is, how do I use the trig functions to find the missing side of a right triangle? How many of you understand 30, 60, 90, and 45, 45, 90? Good. I'm going to make it different now. So what's happening is this. 30, 60, 90, and 45, 45, 90 always work for those two types of triangles, right? But what if I do one that has a 32-degree angle and a 58-degree angle? Then can I use the 30, 60, 90? No, because it's not a 30, 60, 90. So I now need to know how to solve those. I'm going to do that tomorrow. Today I'm going to get you in baby steps ready for tomorrow. Do you understand? So what we're going to do is we're going to get us ready for tomorrow. So this is easy. And then tomorrow we're going to add one more step to it. Okay? So let's talk about the 3 trig ratios. There are 3 trig ratios. If you have a calculator, they are on the calculator. You're not going to use that button today. You're going to use it starting tomorrow. So for today, though, you need to know that we have what's called sine. And we're only talking about right triangles this whole unit, right? So if we're talking about right triangles, there's always a hypotenuse. And the hypotenuse is always located where? Along the side, which is across from the right angle. So sine is abbreviated as this. You do not say sin, it is sine. And sine is equal to opposite over hypotenuse. Opposite over, my water, hypotenuse. Okay? Then we have another one that's called cosine. And I'm going to explain what these fractions mean in a second, but for now we're just going to write them out. We have cosine, which is COS. It's still called cosine. And cosine is adjacent over hypotenuse. There's sine, cosine, and tangent. They still use them. They don't go away. Then we have tangent, which is TAN, but it's still tangent. And that one is opposite over adjacent. Okay? Opposite over adjacent. And I'm going to try to make this as easy as possible, which means I'm going to make another chart, but in a second. So let's talk about what this means. So right here, let's make a right triangle. And let's call it triangle ABC. And we have triangle ABC, and what we're going to do is we're going to look at angle A. So I want to pick an angle so I know which angle I'm looking at, okay? In the homework and stuff, it's going to tell you which angle to deal with, but for now I want to look at angle A. Got it? And what I'm going to do is I'm going to always label the hypotenuse because the hypotenuse doesn't change. It's always located where?
On the opposite side of the right angle.
On the opposite side of the right angle. So that's going to be over here, yes? Now the next two can change depending on what angle you're looking at. So if I'm looking at angle A, opposite of angle A is different than opposite of angle B, correct? They should not be the same. If they're the same, you did something wrong. So if I look at angle A and I go opposite, I'm over here, correct? Okay, so let's label that it's opposite. This is why I circled angle A, so I know it's only related to angle A. Which means adjacent, and we should know what adjacent means because we talked about adjacent angles, but adjacent means next to. So this is next to angle A, correct? This is not next to angle A, it's on the far side, which is opposite. This is touching angle A, which is why it's adjacent. You see that? But if I was talking about angle B, this would not be adjacent anymore, it'd be what? It would be opposite. The hypotenuse doesn't ever change, it's the opposite and adjacent that change, depending on what angle you're talking about. Got it? So, I have this lovely little chart we're going to draw. And we're going to go ahead and call it sine, cosine, and tangent. And the chart is what you need to memorize. Okay? Sine is always opposite over hypotenuse. Cosine is always adjacent over hypotenuse. Tangent is always opposite over adjacent. You need to know this. Got it? And I'm going to shorten up that little chart in a second, but you do need to know what goes where. Okay? So I'm going to give an example. I'm going to make the chart fit the example. So I'll show you. So examples. For example, A. It's going to say find sine. We say sine of angle A or sine of A. Usually it's sine of angle A. Then we say cosine of angle A and tangent of angle A. And today there's not a whole lot of calculation. It's literally just plugging it into our chart and figuring that out. Okay? Tomorrow's when the calculation comes in, and that's when you have to know how to use a calculator. So if you have your own calculator, you need to bring it tomorrow. Got it? But if you don't have your calculator, you're going to have to figure out how to use mine and then how to use your phone if your phone has it. Got it? All right. So let's draw our picture. Still triangle ABC. There's our right angle. We have a side over here of 7. This side over here is 25, and this side over here is 24. What angle am I using? Angle A. So which angle should I circle? Angle A. What I want you to do right now is I need you to label each side. So let's label the first one, the obvious one first. Which is the obvious one? Hypotenuse. So let's label the hypotenuse. Which number is that? 7, 24, or 25? 25. We can go ahead and label it with just an H, because that stands for hypotenuse, right? Go ahead and label opposite and adjacent for me. Which one's opposite?
24.
Put your finger on A. Go opposite.
I told you.
It's 24. Next to it is what? 7. Got it? Did you see how I found the opposite? I literally put my finger and I go across. All right, so right here, we need to fill in this into here, but I'm going to show you how to do that. So I always do this piece, okay? So I always expect this piece. Sine is opposite over hypotenuse. Cosine is what? Adjacent over hypotenuse. Tangent is opposite over adjacent. So I like to put the letters there so I can figure it out. Do you understand? Now, I just fill it in on what I know. So I like to just start here and kind of go down and across. So what is the opposite? Which one is labeled opposite? 24. Is there another opposite in this picture? Yeah, it's over here on tangent. Got it? Do I have hypotenuse? What is it? There is another one there. And what's your adjacent? 7. We good? Okay. I'm going to take it out because I need to write the actual ratio. So the ratio of sine of A is equal to 24 over 25. Can I reduce 24 and 25? No, so there's my answer. What's the cosine of angle A? 7 over 25. Good. What's the tangent of angle A?
24 over 7.
24 over 7. Can those be reduced?
No.
If they can't be reduced, we're done. If they can't be reduced, we will reduce them. Are we good? Tomorrow we'll start to find missing sides. Today we're not finding sides yet. We have one more example that's really 2 pieces.
2 pieces?
Yeah, so like 2 examples in one. And then you should have plenty of time to do your homework. And you better start getting your homework in. Because the homework train has dropped off immensely. All right, ready? Example B. God bless you. I suggest if you have a colored pen or any color, when you go to label this, you're going to want to use a color. Because I'm going to use the same problem again. So you're going to find sine of angle A, cosine of angle A, and tangent of angle A. You have 62, 12, and 24. 62, 12, and 24. I suggest the first thing is probably to do what to the triangle? Label it and circle what? Circle the angle. So what angle we have, and then go ahead and label. All right, so if I look here, where's your hypotenuse?
62.
Where's your opposite?
24.
12. What's your adjacent? 24.
What?
That's right, it's across from it. Make your chart. So sine of angle A, cosine of angle A, and tangent of angle A. You gotta label it right. Sine is which ones? Not the numbers, but the letters. Opposite over? Hypotenuse. Cosine is? Adjacent over? Hypotenuse. Tangent is? Opposite over? Adjacent. Good? All right, fill in what we know. What's our opposite number? 12. What's our hypotenuse number? 62. And what's, our adjacent number? 24. Good? All right, let's bring it out. So we're going to say sine of angle A is equal to 12 over 62, which I don't like. I want to reduce it. So what does that reduce to? 6 over 31. Good? Finish it up. Cosine of angle A, is equal to what? 24 over 62, which is reduced to 12 over 31. Lastly is tangent of A is equal to 12 over 24, which reduces to 1/2. Good, so 1 over 2. Make sense? Good. Now using the same triangle, I want you to find sine of angle B, cosine of angle B, and tangent of angle B. So do I need a new chart? Yes. This is why I said pick a different color to hopefully label. Okay. Ready? Yes? All right, back up to the top really quick so I can label my triangle. We're going to look at angle B now, yes? Opposite, hypotenuse, is that one changing? Nope, stays the same. Opposite of B, though, is what? That one's 24. Adjacent to B is now 12. So I picked a different color so I can see the difference. All right, so down at the bottom I made the chart. Sine is what?
4.
Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Good. Now you can give me the numbers. So B, opposite is what?
24.
Opposite is 24, sorry.
Over 60.
Hold on. I got to fill it all in.
62.
And then hypotenuse is what?
62.
And adjacent is
12.
12. Good? All right, so let's reduce it. So sine of angle B equals 24 over 62, which is reducing to 12 over 31. Cosine of angle B is equal to 12 over 62, which reduces to 6 over 31. And tangent, of angle B is equal to 24 over 12, which reduces to 2 over 1. Jonathan, why are we talking? Do you see how you have to be careful? What do you notice about A and B? Nothing? They're not the same. Some of them flipped. One is a reciprocal. There's no tan here. There's tangent. Tangent's the reciprocal. Cosine and sine did what?
They
flipped them. Yeah. It's a reciprocal, which means it did this. Cosine and tangent flipped, right? So this is why you have to be careful when labeling, because if I pick angle A and you actually do opposite and adjacent, you're going to end up with actually angle B. You see how that works? So that's why you have to be careful. All right? That's why I did both, so you can kind of see the difference. And see how they're very similar, but yet they're wrong if you pick the wrong angle. Got it? We have 30 minutes for homework. It should not take you that long, but good luck. You do need a sheet of paper and fold it up into boxes. You still have summary time. You have questions and summary time.